morning. What I want to do today is just go over how to quickly recall or remember how to fill in a unit circle. And so what I'm going to do is just go through the patterns that I use just to have a quick way of remembering all the important angles and ordered pairs that go with the unit circle. So what you see at the bottom here is just the order that I always go through when I complete and fill in a unit circle. I start with filling in the degree measurements. I always go through all the multiples of 30s, degrees, and then the 45s. And so you can see on the example that I have here, 0, 30, 60 is already filled in. So I would continue going around our multiples of 30 degrees. Be careful that we skip the middle ones here. Those are the 45s. I'll get to those after. 180, 210, skip the middle. 240, 270, 300, skip the middle. 330 degrees, and if you want, we're back to 360 degrees. Then I'll go back and do the 45s. The 45, 90, 135, 180, 225, 270, and 315. And then we're back to 360 when we count by our 45s. So I start with the 30s, the 45s. Then I'll go and fill in the radian measurements. And remember that every 30 degrees is 1/6 pi. And so I'm counting by sixths when I fill in the radian measurement. And so my 30 degrees is 1/6 pi, 2/6 pi. I'll worry about reducing those fractions later. 3/6 pi, 4/6 pi, 5/6 pi, 6/6 pi, 7/6 pi, 8/6 pi, 9/6 pi, 10/6 pi, 11/6 pi, and when I get back here, I'm at 12/6 pi, which of course is equivalent to 2 pi. So now I have my 30-degree multiples. I'll go back and focus on those 45s, and remember 45-degree measurements are equivalent to 1/4 pi, so I'm counting by quarters. So the 45 degrees is 1/4 pi. 90 degrees would be 2/4, which would be the same as 3/6 or 1/2 pi. So that would be 2/4, 3/4 pi. 4/4 would be equivalent to 1 pi, just like the 6/6 pi is. So that would be 4/4, 5/4, 6/4, 7/4, and then I would be back up to here, which would be 8/4. Would be equal to 2 pi. And so that's how I get my angle measurements. Remember, these are standard position angles where the initial side is on the positive x-axis and a terminal side is somewhere around the unit circle. Now I go and do my ordered pairs. The ordered pairs are based all on a few things that we are talking about a unit circle, remember. So I start with my x and my y axes, where I know that I'm going straight across one space, but I'm not going up any. So 1 and 0. 0 cross 1 up is the same, is our 90-degree angle coordinate or ordered pair. -1 and 0 over here at 180 degrees. 270 is 0 cross and 1 down, so 0 and -1. So I do my x and y axes. Then I'll move to my 30 degrees. Now, this is how I remember it, but remember our ordered pairs for a point on a 30-degree standard position angle is connected back to these special right triangles that we learned in pre-calc 20. And what I did with them when I explained this the other day, the original measurements for a special right triangle were 1, 2, and root 3. But with our unit circle, we don't want our hypotenuse. We don't want our hypotenuse to be equal to 2, so I divide it down to 1, and that reduces all the other measurements down as well. So, being that the sides of this special right triangle are 1/2 and root 3 over 2, 1/2 is a smaller measurement. That's what I mean when I say I'm going over a little to get to our points on our unit circle, and over a lot or up a lot to get to root 3 over 2, which is the larger of the measurements. So when I'm looking at getting to the point on a 30-degree angle, I have to go over a lot and up a little. Those are the two measurements that I have there. So then I know that my ordered pair is root 3 over 2 for the over a lot and up a little. All 30-degree measurements are those two values, 1/2 and root 3 over 2. We just have to decide which one comes first, which one comes second, and are they positive or negative. So when I'm talking about a 60-degree angle, to get to that ordered pair, I'm over a little and I'm up a lot. So over a little is 1/2, up a lot is my root 3 over 2. And I continue to do that for all my 30-degree angles. 120 degrees is back a little and up a lot. So negative 1/2 for the back a little, and up a lot is still positive root 3 over 2. 150 degrees. I'm back a lot this time and up just a little. So negative root 3 over 2 is back a lot, and up a little is my 1/2. And I continue along that line. Now that we're down here in quadrant 3, at 210 degrees, I'm back a lot and down a little. Back a lot, negative root 3 over 2. Down a little bit is negative 1/2. 240, back a little and down a lot. Back a little is a negative 1/2. Down a lot is negative root 3 over 2. 300 degrees is over a little and down a lot. Now I'm moving a positive direction for my x-axis, so over a little was positive 1/2, but negative root 3 over 2 is down a lot. 330 degrees, we're over a lot and down a little. So it's a positive root 3 over 2 for my x, and down the little is a negative 1/2. That gives us all our ordered pairs. Now we just have to go back and do our 45s. 45 degrees, again, back to that special right triangle. 45, 45, 90. In pre-calc 20, the hypotenuse was root 2. The legs were both 1. We don't want those measurements for our unit circle. We had to divide to make our hypotenuse 1. And so therefore, correspondingly, the legs become 1 over root 2. Or if you want the rationalized version, root 2 over 2. And these two are equivalent to each other. It doesn't make a difference. I'll use the root 2 over 2, but what's nice for 45-degree angles, that the x and the y values, they're the legs of our special right triangle, are the same. And so all we have to worry about are signs. We are both positive in quadrant 1. So positive root 2 over 2 and positive root 2 over 2. 135 degrees, the x is negative, but the y is positive. But we are talking about the same root 2 over 2. Negative for the x and positive for the y. 225 is back, negative, down, negative. And so negative root 2 over 2 and negative root 2 over 2. And the last one, 330. Oh, sorry, I put this in the wrong spot. Let me back up and fix this. My 330 was supposed to be positive root 3 over 2 and negative 1/2. My 315, back to this one, sorry. positive for my x and negative for my y. So we have positive root 2 over 2 and negative root 2 over 2. And we have all of our ordered pairs and all of our measurements for our unit circle. That's it. Have a good day.